Hi, and welcome to the worked solutions for paper 3. This is the mock set 7 foundation set. So we've already done papers 1 and 2, and this is paper 3, which we've done our best to really not just give work solutions, but to actually give you some top tips, some things to think about, looking at keywords, looking at how to use diagrams, and also the formula sheet if you are a student in 2025, 26, or 27. So download the paper from the description, have a go, and then come and take a look at the solutions with us. 36.82 to the nearest whole number is 37. What percentage of this shape is shaded? We have got 4 shaded out of 10 squares. Now we've got to do that as a percentage, so you just times through by 100, pop the whole thing in your calculator, and you get 40%. Okay, the value of 4. 4 is in the tenths column, so we've got 4 tenths. You don't need to cancel it down because they have not asked you to. Y plus y plus y is equal to 3y. Okay, so we've got to work out which number is a square number. Now, if you don't know your square numbers, remember you've got your calculator to help. So you can put 1 squared, or you could put 1 times 1 into your calculator, and then you can just keep repeating this until you find the right one. This is 4 times 4, which is 16. So 16 is our square number. Okay, we've got to transfer the information from the bar chart into the pictogram, which has already been started. Now, if we look at Wednesday, we can see that there is a total of 8 TVs. Wednesday has been done on the pictogram and it has got 4 squares. That tells me that each square is worth 4. Once I've worked out what a square is worth, I'm going to fill in that key, so that job's done, and then I can go on and complete my pictogram. First thing I'm going to do is look at the heights of all my bars. So Thursday has a height of 4, Friday 6, and Saturday 9. And then I'm going to represent using my key. 1 square is worth 4, so we're just putting in 1 square. For Friday, 1 square is 4, and then I just want half. So just make sure it doesn't look like a square because it's really easy to do that. And for 9, we're going to do 2 full squares and a little quarter. Okay, the problem here is the cost of 1 jar of jam. We know that he's bought a number of items and paid with a £10 note, and he got £4.85 change, and that is actually where we're going to start. So we're going to do 10, take away £4.85, which gives 5.15 or £5.15. That's how much he must have spent. We're then going to take off what we know. So we're going to take away the £1.35 for the spread and the 92p. Now be careful, make sure that you are writing this in pounds. When you take that away, you get £2.88. Now he bought 2 jars. Really important that we clock that. I need to divide by 2 if I'm going to get the price of 1 jar, which is £1.44. Okay, to write down the next term, we just need to see how the sequence is growing, and it is going up 4 each time. So we've just got to take the 17 and add 4 to it to get our answer of 21. The 50th term is 201. Write down the 51st. So that's just the next one on, which means we really do just have to add 4 to that to get the next one. And then we're being asked to explain why 328 is not a number in the sequence. So if we take a look at our sequence, 5, 9, 13, 17, we also know 201 is in it and 205 is in it. This number is very different to all the others because it is even. The sequence is a sequence that contains odd numbers only, and that's how we can determine, without too much maths, without any extra work, why it's not in the sequence. So that's what we're going to write down. Okay, part A is asking us to find the bearing of B from A. So the bearing that you would need to be on to get to B if you are at A. So I always use that word from. From, and then whatever they give you next is the angle you are going to be measuring. So we need to measure this angle here. Okay, so I've positioned my protractor so that the crossing point here is right tucked onto the point of the angle. It's covering the north line to 0, and then I would just follow the 0 around until I hit that line of travel between A and B. So the answer to this is 120 degrees. The next part is going to be using this scale. We know that the scale is 1 centimetre for every 2 kilometres out in the real world. You're going to measure with your ruler the line A to B, and then you would multiply it through. So because the downloading of the paper and then the printing and so on can sometimes change the diagram that you would have been given on the real GCSE paper, your answer may be slightly different. The measure is 4.5. So I've measured that in centimetres, and then I just use the grid to do my trick. It doesn't really require much, and I certainly am not going to really need the calculator. So you multiply along the diagonal, which would give you 9, divide by 1. You've still got your 9. Show what you're doing, and we're done. As I say, you may get something slightly different just down to the way it's been downloaded and printed. Okay, so we've got blue and red pens in a box, and we've been given a ratio. So the first thing we're going to do is code that ratio out. So we've got blue to red, 5 to 3. We've got to work out what fraction of the pens in the box are red. Well, there are 3 out of a total of 8 pens. So that is our fraction. Okay, to write these in order of size, we really need to have them in the same format, all different percentage, fractions, decimals. We can't compare them. The best thing to do is to change them to decimals, and the best thing to use is your calculator. I see so many students not making the most of their calculators. So we're going to divide through by 100 to change the percentage to a decimal. And then we can just use our calculator to change fractions to decimals really easily. And of course, we've already got a decimal on the end. Now, the next thing is to get your decimals so that they have the same number of decimal places. Just makes them so much easier to compare. So when we look at these two, there are 4 decimal places. This is 3, this is 2. Let's get them all 4. And by doing that, we can then just see or pretend it's not technically true, but we can look at this like it's 7,180 or 7,142, 7,100. This is clearly the smallest, but it just helps us get them in the right order. When it comes to writing them on the dotted line, revert back to the numbers you were given in the first place. Okay, we've got 80 litres of water in a tank, and then it's flowing out at a rate of 125 millilitres per second. So the first thing to clock is our different units. We cannot be working in different units. So we're either going to change everything to litres, or we're going to change everything to millilitres. We're going to, well, I'm going to change things to litres. There are 1,000 millilitres in 1 litre. So 125, in fact, let me do it this way. So 125 would equal, and the way that we can do this is use a little grid, multiply through and divide. So a great little grid. That's going to give us 0.125 litres. I'm going to use this grid again. I know at the moment that 0.125 litres is flowing out of the tank per second, so every second. Got a total of 80. Now I'm going to multiply across and divide through. 80. Technically, you don't need to times by the 1. Divided by 0.125 gives us 640 seconds. This helps us structure the numbers in a way that we know what to do with them. Then we do the maths, but do show it. Don't just tap it in your calculator. The examiner wants to see this. It's part of your method mark. Okay, we got a rule, which is to multiply the number of days by 9 and then add £7.50. So if we're hiring it for 3 days, we're going to be doing 3 times 9, which is 27, and then add on your £7.50, £34.50 is your answer. So Andy hires the cement mixer and the total cost is £106.50. We've got to work out the number of days. So this is a backwards question. If the total cost was 106, if you think about when we worked out this top one, the last thing we did was add on the £7.50. So the first thing we're going to do is take that off. So 106.50 take away 7.50 is going to give you 99. The rule is to times by 9. So we're going to now divide through by 9, which gives us 11 days. Now, another way of doing that is to write the rule as a function machine. So you've got your days going in, they get multiplied by 9, you add 750, and then you get your total cost coming out. If you've been given the total, then you are going to start here going backwards. And as you go backwards, you do the opposite. Keep going backwards, do the opposite. So that's just, and then you get your answer of days. So it's just another way of setting it out and just thinking about it. Chloe hires the cement mixer for Y days. What they've done there is they've just tried to give you a letter to represent your days. And the total cost is T. You've got to write down a formula for T in terms of Y. Now, these questions are really off-putting. There's lots of language, there's lots of letters. Often we don't like that. So we're just literally going to follow through with all the knowledge we've got from the first part. We know the total cost is equal to 9 times the number of days plus £7.50. But we need to now change days for Y because that's what they've asked us to use. And we also don't show the time sign. So this would become 9Y plus £7.50. And that would be our formula. Technically, we don't need that 0. So we could lose that for our final answer. But if we were to keep it on, it would be absolutely fine. You would still get your marks. Okay, finding the value of Y. Now, the top tip here, if you're not great with angles, the most important thing is not to fixate yourself too much with what they want you to find, but find everything and anything else that you can. I can almost guarantee that you will get marks using that method. They are saying that we should be giving a reason for each stage of our working. So do that as you go as well, and you're adding even more opportunity to score marks. It's a 4-mark question. So we want to get as many as we can. So I recognize that this 40 degrees here is 40 on this side because they are opposite angles. So I know that's 40. And I'm going to write it down straight away before I do anything else. I also know that the 65 is on a straight line with this angle. And straight lines add up to 180. So if I take away that 65, it tells me that this angle is 115. And again, I'm going to write down my reason. Now I've got enough information to find the Y. The Y is in this triangle here. And I've got these two angles just by doing what I can see and not overthinking it. But I now have these two angles inside the triangle with Y, and that's how I'm going to finish it off. I'm going to take away 155, that's the 115 and 40 added together. I'm also going to give my reason. And there you've got it. All right, there are various ways that you may approach this question. I'm obviously going to do it the way that I would be teaching and encouraging my class to do it. As soon as we recognize it's a percent question, we should be giving the question a tick and then looking to see if there is an increase or decrease in the story. And there is a decrease in this story. That tells me that it's going to be original times multiplier equals result. My job is to work out the multiplier. So 100%, take off the percentage in the question because it's a decrease, would give me 88%. You divide through by 100 to just get the decimal version, and our multiplier is 0.88. The rail card was £30, and that gives us 26.4, or if you want to write it, is money, £26.40. So that is going to be the cost of our rail card. Now, using this rail card, Dan gets a third off the cost of his £84 ticket. So we've got to now find a third of 84. We divide by the bottom, times by the top, if we're doing non-calculator. If we can remember of means times, then we can just throw a third times 84 straight into our calculator, and we would get 28. Now that's a third off. So that's what's going to be taken off of the total cost. So 84, take off that 28 is 56. So the ticket is now going to cost 56. We've got to work out the cost of the card and the ticket. So we now just got to take our £26.40 and our 56, add them together for a final answer of £82.40. All right, this is just a case of carefully filling in the information, making sure that you've read it really carefully. I think the errors that I generally see when I'm marking mock and GCSE exam papers is there's been a misunderstanding in the reading more than in the maths itself. So we've got 120 students in total. They're already in place. 78 study history. Remember, these two will add to make the one in front. So to work out a missing one, I'm just going to be doing 120 take away 78. And then I can pop that in. 45 of the students that study history also study art. So study history, study art. And then 53 of the students do not study art. Well, we can work out easily how many are in this section because we know these two must add to make 78. So 78 take 45 is 33. And then if there's a total of 53 that don't study art, the other 20 would need to be down there, enabling us to complete that diagram. Now, one of the students who studies art is chosen at random. Now, I've got a total of 67 that study art. Find the probability that they do not study history. Do not study history is going along this branch here where you've got 42 people. I want to know the ones that study art but not history. So that would be 22. So the probability is 22 students out of the 67 that study art. All right, we've got to work out which milk is better value for money. We need to be able to compare. Now, I could cross multiply, times this by 6 to get 24 pints worth, and times this by 4 and get 24 pints worth, and they're the same. But I think with these types of questions, you never really know what type of question you're going to see. When you're comparing, most often it's better to just go down to 1, and that's what I'm going to demonstrate here. So for my 4 pints, if 4 pints cost £1.08, if I divide through by that 4, I can work out what 1 pint costs. And then I'm just going to repeat that with my 6 pints. Now I've got the cost of just 1 pint, I can compare them. I can see this is slightly cheaper, which came from my 6 pint bottle, and that's what I will be writing. Okay, so this question is testing our knowledge on the topic loci. So if this is unfamiliar, then that's the thing to go and search and do a little bit of work in. So it is loci, L-O-C-I. Okay, so by following some rules, we are going to create a region. Now, the first rule that we have been given is that we have to be less than 4 centimeters from A. Now, I'm going to just give you an idea of what's going to happen here. If we just pretend that this point here is 4 centimeters away, and then this point here is 4 centimeters, and this one here is 4 centimeters. And let's put this one over here. That's 4 centimeters away. You start to build the shape that the points make. And you can see that they create this circle. So to get our circle right, we're going to use our compass. So if this was our ruler, 0, 1, 2, 3, 4, we would stretch our compass out so that the pencil was lined up with our 4, and then the distance between the two arms will be 4 centimeters. You stab the cross that you've been given for A, and then you would just draw your circle. So this isn't to scale, this is just to give you an idea. So you would draw your circle, and that would be your locus of points. That's how you get the first rule done. The second rule is you have to be closer to B than to A. So I need to draw a line slap down the center that will split this perfectly in half. To do this, I'm going to be using a perpendicular bisector. It's still our compass work. So I'm going to take my compass, stab the A, stretch the legs out so that they're kind of 3/4 of the way along. And then I would arc the top and arc the bottom. I don't have to arc. I could do a full sweep and create half a circle. I could draw the whole circle if I wanted to. But little arcs just provide a little less lineage to get confused by. The arcs, when I say little, still need to be long enough so that when you stab the other side, and what's really important here is you don't cause any movement to the compass legs. We need it to be the exact same distance. They cross as well. If they don't cross, let's say I got there and my red one was here, just means my red one needed extending and I might need to go back to make it long enough. But you will get this crossing action, top and bottom, and then where they cross is where you draw your line. Obviously, mine has just jumped. So the final answer is going to look like this. So here's our 4 centimeter circle where we had to be closer to that A. We had to be less than 4. I've got the construction lines still showing. Don't ever rub those out. It shows that you did it the right way and you didn't just draw a straight line that was roughly in the middle. Okay, so you've got that, and then the 2 enclose this. So this point here, for example, is closer to B than it is A, but it is still less than 4 centimeters from A. And that was what we were trying to achieve. Okay, we need to make Y the subject. That means that we want Y on its own. To get Y on its own, we're going to need to move the 4 and the M. First thing I'm going to do is get rid of this fraction, get rid of this divide by 4 by bringing it across. So it will land as its opposite, times by 4. So we've got 4D equaling Y plus M when we finish that step. And then we're going to take the M across and it will land as take. 4D is already there. And then it lands as minus M. So our final answer is Y equals 4D minus M. Okay, so we've got a story about sweets, and the number of green sweets in the box is 3 times the number of blue. It's a probability table. Probabilities have to add to 1. So I'm going to do 1 minus 0.4. That's the 0.3 and the 0.1 added together to give me 0.6. The 0.6 needs to be split in a way that enables the green to be 3 times the number of the blue. Now, if you can see it, it's great. But if you can't see it, this is where your calculator is going to become incredibly useful, because you can just trial it until you find the right thing. So what I mean by that is you could say, okay, if blue was 0.1, then times that by 3, it means the green would be 0.3. But these two do not add to 0.6. So that's not the right split. So then I might try 0.2, which would give me 0.6. And obviously that can't work because I need two numbers that will add to 0.6. And if 0.6 is there, it's kind of not working, is it? But what it does do is it gives me a feel for the fact that I must be lying in the middle. And halfway between those two would be 0.15. When I've worked that out, I can see that these two add to give me that 0.6. So now that's in the table, I can start thinking about the next step. This is just modeling a way of problem solving. As I said, some students might automatically be able to make that split and not need to put all this work in. So don't feel that has to be done in order to get the marks. It's just a demo for anybody that just feels a little uncomfortable with these types of questions. Now, we are being told that there are 18 yellow sweets. So our 18 is being linked to the probability of 0.3. I'm going to put that fact into my grid. So I've got 0.3 and 18 as my fact. I'm being asked to work out the number of green sweets. The probability of green is 0.45, so it goes into that section. And then I follow my normal, multiply across the diagonal and divide by the corner. I'm going to write that out because this just structures my actual numbers. This is the maths the examiner wants to see, so it's important that we write that down. Put it in your calculator, and the answer is 27. Okay, this question is really testing that you know how to use your calculator efficiently. You would put this into your calculator using your fraction key, using all the right thing. It should look identical to what you're looking at in the question when you press that equals. The answer is 1.207620601. That was all the figures that were displayed on my calculator. But notice how I've written one thing and it's a 2-mark question. I would never risk that ever. If it's 2 marks, I'm going to give them 2 things to look at. So I'm just going to go back up and choose a part of this to work out. And I'll just do the denominator because it just has an easier feel to it. So I'm putting that in the calculator and I'm writing that down. So I've definitely got some method as well. Write your answer to 3 significant figures. So that's part of the number that we had. 3 sig fig is just count 1, 2, 3, cut. 7 is greater than 5, so I'm going to add 1, and my final answer is 1.21. So we're being told that the area of a rectangle is 12 meters squared, and we need to work out the area of the rectangle in centimeters squared. The biggest mistake is using 100. We use 100 because there are 100 centimeters in a meter, but we're not talking about centimeters in meters. We're talking about centimeters squared and meters squared, and they are completely different. So that's the first mistake I see. So that is something we must not do. One of the ways that you could approach this, if you're not sure about the links between the areas, is to just model it, to just draw it. The area of a rectangle is base times height. So we've got our rectangle. We want the area to equals 12 meters squared. So we could say that this is 4 meters and this is 3 meters. I could have done 6 and 2, I could have done anything. But we know that is an accurate picture of what they are saying in that first line. All I now have to do is change my units. 400 centimeters is in 4 meters. 300 centimeters is in 3 meters. If I multiply those, I get the rectangle in centimeters squared. And that would be our final answer. Okay, we've got quite a wordy question about pens and pencils, boxes and packets. One of the best ways I think to approach this type of question is to, again, do that model, draw pictures. We work in diagrams and symbols, in codes and patterns. That's how we work in maths. We don't want all these words. So I think the first thing I would do is just say, okay, I've got a box and that has 40 pens in it. And then I've got a packet, probably not really going to change the look of it particularly, but that's got 12 pencils. So we're going to be giving a pen and a pencil to each student in year 7. And when she's finished, there are going to be no pens or pencils left over. That tells me that I want the same number of pens as pencils. So I need to think about the multiples of 40 and 12 in a way that means I get the same number. So 40, if I bought another packet, or another box, I should say, I'd have 80. If I bought another box, I'd have 120. Now I'm stopping there because I'm already sensing that 120 is in my 12 times table. So I would think about, okay, it goes 12, 24, 36, etc. Is 80 in the 12 times table to match with this 80 that I can get here? And the answer to that is no. So I go to the next one, 120. And I've got yes. So 120 pens and 120 pencils are what I want. I can see here, because I listed them, that that would be 3 boxes. So I'm going to be getting 3 boxes of pens. And then I've just got to think how many 12 are in 120, and that is 10. And remember, you do have your calculator to help you with all the maths there. Okay, these questions are quite common. I'm seeing these all the time at the moment. What we want to do is take the formula that they've given us. We'll just shorten it down a little bit and then look at what we've got. We've been given the force. So I'm going to replace the F, and then we've been given the pressure. So I'm going to replace the P. And what we want to find is the area. So we need to get the A on its own. At the moment, it is a denominator. So I am going to move it to the other side to get rid of the fraction. And a divide lands as a times. So I would end up with 2000 A equaling 29400. But I can get A on its own now by moving this times 2000, and it will land as divide. In effect, they are literally swapping places. And if you know that, then you would just swap places. You put that into your calculator and you get 14.7 meters squared. Now, something to note. The answer, the dotted line here at the bottom, does not have the units. So one of your marks, 100%, is going to be linked to that meters squared, because they've not given it to you. So make sure you're picking that information out of the question. Okay, so the coordinates of the turning point, I think these ones are answered quite well because it's generally obvious where the graph is turning, but it's turning here. This is the point that they want us to find. Remember, it's off the x-axis first and then the y. So it's 2 and 5. And then we've got to use the graph to find estimates for the solution. Now, note that the equation here matches the equation here. So our y has basically changed to 2.5. Y equals 2.5 is the line here. Now we've zoomed in so that we can drop the crossing point. So we put the y equals 2.5 onto the graph, and it crosses our curve here and here. It crosses in 2 places. Now I want to drop down and mark on the x-axis, and then I want to work out what those values are. Checking that your scale is going up the way that you think. This one is going up 0.1 each time. So this is going to be 0.4 and 3.6. Now, they are expecting accuracy here because everything works really nicely. They have allowed a tiny little bit of variation, but not much at all. So if you put an answer between 0.4 and 0.45, you would get the mark. And for the other one, it was 3.55 to 3.6 to get the mark. So accuracy is key for sure. Okay, we've got a percent question, so tick. And then we have got compound interest. Now, compound interest is an increase. So we've got our second tick, and it's also a period of time. So we've got this extra information as well. It's going to be original times multiplier equals result. So we'll do save more first. We've got our original of 5,000. We will be timesing that through by 1.0125. Our multiplier is 100% plus the percentage in the question. And then to get it in its decimal form, we divide by 100. We saw that earlier in this paper. And because we have this period of time, it actually gets added onto the multiplier as a power. So we will put our 3 and we will throw that in our calculator. And that is the amount we get with save more. So now we're going to look at Highbrook, who's got a slightly different thing. We're going to earn 2.1% for the first year and then a different percent for the second. Don't think you can combine these. They must be done separately. So this is our first year, and then our total is used for the next 2 years. And it will be to the power 2 because the first year has already been done. We can see that Highbrook earns just that little bit more interest, and that would be the place to invest our money. Now, remember, you do have a calculator. So if you're finding it hard to get that multiplier, just pop it into your calculator. So, for example, this one here, it looks so complicated, but all it is 100 plus 0.95, and then you divide by 100 to get the decimal version. The second part to this question talks about Save More changing its interest each year to 1.15. Well, that interest is less than it was before, meaning she'll get back even less. So it's not going to make her change her mind at all. Okay, so we need to work out the value of x and y. We're being told that the trapezium has a line of symmetry, which goes on to tell us that these two angles must be equal. And we're going to use that to help us find x. So 5x minus 24 is equal to 2x plus 3. I'm going to take off the 2x, which will give me 3 x's, still got my minus 24, still got my 33. And then I'll go on to solve and get x on its own. So we've worked out that x equals 19. I'm going to put that 19 into this expression so that I can work out the size of that angle. So I know that angle is 71. If that angle is 71, then this angle is 71. 360 degrees in a quadrilateral. Take away your 142 and then divide your 218 by 2 to get 109. So I now know that this angle and this angle is 109. And I will use that to finish it off to find y. So we know x is 19 plus 3y. That is equal to 109. And then I'll go on and get y on its own. So x equals 19, y equals 30. And it's not the only way. I chose to use the quadrilateral and 360, but you could have just chosen to use one side and work through with that 180 instead. Okay, if you're sitting your exam in 25, 26, and 27, you've got the formula sheet, and the formula sheet has what you need on it for this particular question. We are being asked to find the length of AB. So we're looking for a missing edge. Now, Pythag will help with that, but we need two sides and we don't have that. So we're going to forget Pythag and move on to trig. Using your formula sheet, you would be able to label this side as A, as its opposite our given angle, which would be capital A. The right angle points at A and B, and that would leave that side as C. Now, this side is important because I want to know what it is. This side is important because it's got a value on it, which means it's going to help me. This just has C on it because I put it there. So C is the letter I don't need. A and B is the letter I do. So I look on that formula sheet to see where A and B are together. And we have got from the formula sheet, tan A equals A over B. Now, I still like setting this into a formula triangle, or at least the middle part. So the tan A is written first, and little a at the top and B on the bottom. I would then replace that with the information from the diagram. So I've got tan 43. I've still got my little a, but my B is 3.9. A is the edge that I want to find. I write that down first, then my equals, and then I do exactly what it tells me. These are side by side, so I need to multiply them. Put that in your calculator, and that's what you get. We've got to round it to 1 decimal place, so we're cutting here. 3 is not big enough to round, so the answer is 3.6.